Bonjour tout le monde. Welcome to another episode of the Point of No Return podcast, the show where we go behind the scenes to understand the secrets and strategies of the most interesting Canadian technology companies. On this week's show, I had the pleasure of speaking with Hugo Larochelle, research scientist at Google. I've been trying to get Hugo on the show for a while. I'm really happy he accepted. I think it's a great way to close off 2022. So my last podcast of the year. I think I've had a pretty good run this year, and I think it's a great way to close off this year with Hugo. And we really spoke about some fascinating subjects. Of course, we spoke about the advances in the world of AI. If you've been following a little bit, you've seen how much progress we've had over the past year. So it's really fascinating. And Hugo and his team have been really at the forefront of this. So Hugo helps unpack a little bit of these advances, where they kind of situate themselves in the landscape. We spoke about teaching and his devotion to teaching, him being a YouTube sensation, and this notion of open source, right? The computer science and AI more specifically have this tendency of sharing online, and Hugo has been a great teacher in this regard. And then we spoke about giving back. So Hugo and his wife made a really significant donation, which we talk about on the show. So this notion of why it's important for Hugo to give back, for him personally, I think it was a great topic. Hugo is really one of the most well-known people in the world of AI, and it's been an honor to have him on the show, and I hope you enjoy today's conversation. Hugo, it's a real pleasure to have you on the show. I think a natural place to start, obviously, for me, we're going to talk a lot about, artificial intelligence, deep learning, but I want to start the conversation about teaching, because I see you as a great teacher, one that publishes research, but also your teachings online. So, just curious to hear you. Why do you love teaching so much?
Yeah, and it wasn't a natural thing to do. I after doing my postdoc, so finishing my studies, I was seeking out a position that allowed me to continue doing research, and really the only option, especially in Quebec at the time, was to go to academia and get a faculty position, and so. But interestingly, I never really taught. And I think that's the situation for a lot of new faculty. And so, I mean, it was definitely like a steep learning curve, just learning how to do that properly, realizing that the first realization I think a lot of people make when they teach is that they realize that what is obvious to them is not to the students, and you really have to, what it feels like, dumb it down, but which is really just putting it at a pace that's reasonable. And so I started doing that. I was really lucky at Sherbrooke. I was given classes that was close to my research interests. So I taught intro to AI, and then I got to create a class on neural nets and on machine learning as well. So I never had to teach intro to programming, for instance, which is obviously something everyone has in common in the CS department, but is much more removed from, say, your core research interest. And and when I was doing that, I also was at a time where MOOCs, so massive online courses, started becoming popular. And I thought that was a way of teaching that was really, really fascinating, and that with which I could really connect. I could see myself as a student really enjoying the idea of going online, watch some videos at my pace, maybe watching certain lectures more than once, and uh, to really sort of give myself the space and time to be able to understand the material, and then later on ask questions, maybe to the professor or something like that. And so I started thinking, well, maybe I want to do something like this for my own classes. And I discovered this notion of flip class, where the idea is that you flip the time that you would spend learning about the material and the time that you spend doing your homework, solving exercises, and really applying the material. So normally you learn the material in class and you do your homework at home. But in a flip class, you flip that, you actually learn the material home, and doing it with videos is actually much more approachable for a lot of people. You could do it with books, but I think a lot of students, me included, find that a book is really hard to sort of approach, especially when if it's something entirely new. So so you would watch some videos at home, and then when you come to class, you would do exercises, and you would have more time to do your homework in class, and the professor would be there to answer questions. And so I thought that was a really compelling model, and I was really fortunate. So I was at the University of Sherbrooke at the time, and the faculty and the department really supported me in trying out this new model. And And generally, like the feedback was pretty positive. It was the result were at least as good as when I was doing like normal master classes and the normal teaching. And what I found was that there were a lot of benefit, at least for me, in doing this. One was that I was creating material that I could put online on YouTube. And that was actually useful for, in terms of just always being able to reuse some of the work and the effort that I put in, but also sharing it with many more people. And this actually allowed me to kind of, I think, probably be even better known in the area of deep learning because I a lot of people actually would approach me later on at conferences and be like, "Oh, I saw your YouTube courses," and it's really interesting. Like if you're somewhere on YouTube, somehow people feel compelled that they should take a picture with you, and so this started happening. I'm pretty sure because of that, and so that was like in terms of sort of putting my name out there and building a reputation. That was really useful. But also, the flipped class model was such that I spent much more time solving each misunderstanding of individual students. And I felt much more useful. And I felt my relationship with the students was much nicer this way than doing a lecture and trying to make it entertaining or which you kind of felt you had to do to just keep the students engaged, which I always had a hard time doing. I it just didn't come naturally, but also I kind of felt like if they're paying to be in class, I shouldn't have to do this. They should understand the value of actually paying attention, and which I know is not how it works, but it was hard for me to go beyond sort of that perception, and you kind of felt like you were boring them as opposed to like being there to help them actually finish their homework, solve an exercise, and be ultimately successful in the exam. Um, so I felt my relationship with the students also was much more fun. And in a way, like for some other, I think, professors, maybe it seemed like a lot of work, and in a way it was, but um, certainly doing the first videos, which kind of requires you being alone in front of your laptop, talking to yourself, really, and that's something that's initially is a bit odd, but once you get beyond that, um you I started actually really enjoying it and doing like the production after and really thinking about, also it forced me to really think thoroughly about the actual explanation I gave to every single concept, and I started being good enough at it that I could actually do. So the first time I would, for instance, I taught the machine learning class. I decided to record the videos while I was teaching. So I could essentially kind of produce videos from the first time I would teach in a more normal way. For that semester, I was teaching that class. That was kind of useful for the students, anyways, because then they would see the recordings and they could watch it after. And then the following semester, then I just used the videos and it was a proper flip class. But actually meant the first time I gave it, I came in much more prepared because I was like, okay, there's one take. So I got to give this part of the class really well because if I stumble on my explanation, I'm going to look silly. It's going to be hard to edit it. I might need to reshoot the video. And so it made things exciting, and I think it made it such that I was also more willing to put extra effort into teaching my classes. So I think like it's interesting because you commented me, I guess, on my teaching and so on. But in a way, I never thought I was really all that good. It's just I put myself in conditions where I was energized to do it, and that was one way of doing that. I felt I was innovating, also, so it almost felt a little bit like research. And I don't teach anymore. I still advise students in my new position, but I don't teach. Sometimes I maybe give one class, sometimes, but I still have people asking me questions on YouTube, and then sometimes I'll answer them, and that kind of scratches that itch of teaching a little bit. Also get comments where people say that I have a weird French accent, but I've learned to go beyond that at this point. But yeah, it was. I'm really glad and proud that I got to do this, and that's something that is sort of still rewarding to me.
Yeah, I love how you've like, it just feels like a more natural model and way to learn, right? Where it's like you're at home, you're listening to a lecture, you can fast forward, rewind on parts you don't understand, and then you're working on the difficult, hard parts with your professor, with your fellow students. Just feels much more natural. And to your point of putting things up on YouTube, I find it's like it's a very fascinating but complex subject what you're teaching, so it lends itself to like, hey, people wanting to watch it and learn from it. What's been the most surprising thing in your years of teaching? Has it been, the growth of interest? You said people wanting to take selfies of you, like, you as a YouTuber. Is there any other like things that surprised you along the way?
I mean that's probably number one, the weird little fame that came with it. But if I couldn't call it that, but actually one thing that um, kind of maybe also surprised me, which is a little bit unfortunate to some extent, is that I was trying to convince other professors to use my material and do the same thing, and I saw a bit of resistance, which I mean, which in some way I can understand. If the material is not taught the same way you would teach it, then maybe it's harder for you to kind of use it as your own material. Um, but I feel sometimes also, I mean, maybe some had the worry that it almost seemed like they were being lazy, as they're like as if it looks like they're not even teaching the class themselves, which I think is really a misconception, because there's a lot of preparation and work that goes into, and performance that goes into going into the class and solving exercises with everyone. Because now every single class is different. You don't know what kind of ways in which that particular cohort will have misunderstood the material. And to me, that was a big motivation also for teaching with a flipped class model, is that my mental model was that there's like there's more or less one way of understanding the material, but there's like millions of ways of misunderstanding it. And every different student will maybe misunderstand it in a different way. So therefore, that requires a really personalized approach as much as possible in terms of addressing misunderstandings. Like sometimes I might do an intervention in the whole class and I might be like, okay, I'm getting similar questions. So I'll clarify this for everyone. But oftentimes, I just get one question that is just this particular student who misunderstood this particular thing in this particular way. And I can kind of do an intervention just for that student. Um, and that is, I mean, also discovering that I think was a little bit of a interesting surprise that to me led me to sort of add motivation for teaching in this particular way.
Yeah, but also it also feels like the field of AI generally is one where, for this from the outside looking in, it feels much more collaborative in nature than
Mm.
other fields of academia, where it's like you look at all the cool research, the cool breakthroughs. It's a lot of people working concurrently with different schools, different firms. So it kind of lends itself to sharing, publishing right away versus the classic peer review model. I don't know if this is an accurate assessment. Again, this is maybe an outsider's view.
I think there's definitely some truth to that. I think probably in, at least in computer science in general, this is an area that will, well, a lot of people embrace the notion of open source kind of naturally. So that will lead to cooperation and collaboration as part of that model. I think one thing that people have found is particularly unique in machine learning. Well, certainly there's some willingness to really put the research out there as fast as possible. I think we well, at least, I'm not completely aware of other fields that have embraced the kind of open reviewing also approach to the way we evaluate our research. We had the iClear conference, the International Conference on Learning Representations, and a lot of what was behind this conference was this idea that actually when you submit work, as soon as it's submitted, it's visible to everyone. Normally, it's not, and even machine learning before iClear, that wasn't how people would approach reviewing. And then you would actually see the reviews that are being submitted for every work, and even anyone could submit any comments on the submitted work. And so that is, again, like, I think this is maybe indeed going a bit further than perhaps other disciplines in terms of being open about sharing your work, but also sharing and collectively kind of analyzing and criticizing the work that gets out. So that's maybe one way in which it is perhaps a bit unique, but also the collaboration between people in industry and people in academia is also very deep and open. That's particularly true in Montreal, and I think that is something that I love about this community is that, I spend some of my time, even though I work at Google, I'll spend one day a week at Mila, where I'll see professors and students. I advise students there, sometimes jointly with professors. And and I think this actually has happened because, when we started really making a lot of breakthroughs in machine learning and deep learning for AI, and there started being interest in industry and hiring, people with that expertise, we came with that set of values that we thought open collaboration was really important. And so I think this sort of comes from that. And I know that, I mean, in Montreal, that has been this is a value that people like Joshua Benjo has been really pushing for. And I've sort of, grown up as an academic with those values really embedded in my training. And so I think a lot of it comes from that.
Yeah. It seems like you guys have like very positively infected, the large companies that, like you look at things like TensorFlow, like, and also like Facebook and other companies just publish and open source what they're doing. You've also been a very prolific researcher, right? You've published, I don't know how many articles, but a lot from what I saw. How has it changed the process for you of doing, research?
hmm Um, I would say that, well, it depends where you start, but certainly as a PhD student, writing a paper was like a huge thing. It starts off being like almost, it all seems like such an uncertain and unsurmountable thing to do. And interestingly, when I got my first paper, I think something kind of clicked. And in particular, when I got my first paper where I was the first author on it, and it was really my idea that I owned. So then it became much more easy. You start understanding that there are elements of it that are really important. Like there's a form of storytelling that comes with a paper. Like what is the so you would think about science as just being kind of a dry layout and hypothesis and run some experiment to be able to kind of falsify or confirm that hypothesis. And the core of a paper is that, but it's also not just that. It's understanding why is this important. um, you need to motivate, why should people be excited about this work, and that is a form of storytelling. Like you need to develop that ability. And with time and practice you sort of start becoming better at that. Initially you also kind of publish papers are we anchored in a very specific question you're trying to answer, and with experience you start developing more of a complete research agenda, a sense of a longer term goal that you're trying to achieve, and you start sort of seeing how all of your interests and all of the problems you're trying to solve kind of fit within that research agenda, and that influences the next problems you're trying to pick. And so, I sort of, through my PhD, I sort of get to understand that a bit more, and my postdoc as well. And then when you start being a professor, having your own lab, and certainly now that I'm at Google and I have a group where it's a bunch of research scientists who all have their own research agendas and their own interests, then it starts being a little bit different, the role that I play, where it's more about shaping the direction, um, providing an external voice as to like where they might be having blind spots, the people owning or leading the research. Um, Sometimes the analogy that I give is that I, when I was a PhD student and sort of really owning certain papers I would write, I was kind of like an artist producing albums, and now I'm more like a producer who's kind of producing other artists, or hell, essentially supporting other scientists that are trying to sort of make progress in their own research agenda. So that's one way in which my role and my work in terms of publications has really changed. And also I've had the chance of really get involved and have a lot of fair amount of influence in how we publish research. I've been involved at conferences. I've organized iClear that I mentioned before a few years, and was on the board of that conference. I organized NeurIPS, which is the top conference of the field, really, probably the most prestigious one. And I'm on its board now, and on the board of the ICML conference as well. And I started getting really increasingly interested in thinking about what's the right way of for us to evaluate and disseminate our research. And more recently, I created a journal, the Transaction of Machine Learning Research, and and that has been also kind of something I'm mostly busy with these days in terms of my involvement in publishing, uh, we're trying to adopt this open reviewing model, but for journals, which is something that is, the machine learning community is mostly driven by conference papers. But that means sort of like always have to think about what's the next conference deadline. So you're really deadline driven, which is useful in some ways of, it forces you to get stuff done, but it's also very stressful. And whereas if you have a journal, you can submit anytime. That's kind of, in a way, possibly healthier in terms of doing good science. And so I wanted to sort of create maybe a new publication venue that where you could submit anytime, and a journal seemed like the right thing to do. And the open review model was not really a common thing in that area. So that's something that, we launched that journal earlier this year, and it's been going pretty well. And I think we can do a lot more around this kind of model.
Maybe a question for left field. You go and feel free to contradict what I'm going to say, but it feels like you're at the ground floor of an industry that didn't exist, like 10, 15 years ago, right? Like all the innovations have just blossomed now. We could talk about GPUs and like Jeff Hinton and his influence, but this is very recent, right? Versus if you're a PhD in mathematics, well, math has been around for a while.
Mm-hmm.
So how do you have a sense of perspective of like, it almost feels like you like all the work that you just described is almost to an obligation of we're building a new field that didn't exist
Mm-hmm.
prior to this century. Is that a right frame that you kind of look upon this emerging field of AI where we're just building the real building blocks of this now?
I think it's true in perhaps in some ways, in that it feels like uh that the field is quite different from what it was before, the broader field of AI. But the term AI has been used to mean many things over the years, and there's definitely been like blooming periods and AI winters. Like we literally use that expression to describe certain parts of the history of AI. Um, and now we're kind of in a blooming period that's really driven by deep neural networks and this notion of deep learning. Um, when I did my PhD, machine learning was a decently important field, and was definitely machine learning research and machine learning technology being adopted in industry. I think now it's taken a scope that's much wider. It's embedded in many more things than it used to be. And now it's driven by very different types of methods, perhaps, than when I started my PhD. So when I started my PhD, in fact, not a lot of people did neural networks. Like in a way, neural nets were an old technology, which seems weird to say given how now they're everywhere, and we just call them deep neural nets, or we call it deep learning. But um, and it was a little bit depressing, really, initially. Like I remember one of the first papers we sent out. Some of the reviews were kind of saying that, "Oh, this is using neural nets, so that's not really interesting." Because at the time, people were more interested in kernel methods and methods that could be solved by convex optimization and things like that. Whereas neural nets were associated as this kind of like black box that needed sort of almost dark magic to make work, and you needed to have this kind of unreliable insider knowledge to really be successful with them. And so that has certainly changed. But I wouldn't, because I think there AI has made some progress in a way that looks more like a steps than like a steady linear progress. And now we're certainly in a phase where I'm seeing things in the field and the kind of technology that's enabled by deep learning that I certainly didn't expect when I was doing my PhD. It's really felt like an exponential acceleration of progress.
Yeah, it was going to be actually my next question about like the most surprising, let's say, recent advances. At least in the past 12 months, it feels that there's been so many cool developments, be it from GPT-3 or DALI and all the buzzword of generative AI
Mhm.
startups coming up. But it feels like we've hit an inflection point of a bunch of new innovations, right? And like a lot of it's, I think, large language models
Mhm.
that have evolved. How much of this is based on new innovations versus just like, hey, we've just built upon existing deep neural nets
Mhm.
and existing work and research from the past few years?
Yeah. So I think certainly some of the elements that are behind, say, GPT-3 are relatively new, like the transformer architecture, which is this kind of neural net architecture, uh, and some of which elements of which the notion of it uses the notion of attention, and that's something that's really been that I associate that's coming out from Joshua Bengio's lab. So this is one of the influence that the Montreal community has had on this. But the transformer architecture, and that comes from Google, is definitely like immensely important, or it's turned out to be immensely important for training these large language models on tons and tons of data. And that's a relatively recent, innovation, attention or transformer networks. Um, Also, for image generation, the breakthroughs we're seeing now, a lot of them are based on this notion of diffusion models, and that is also actually relatively recent. It's I don't remember when that work has been published, but the first sort of diffusion models that people would cite, but it's certainly within the past 10 years and maybe even 5 or 6. So it's actually relatively recent stuff, but I would say that there's also a little bit of a kind of genius insight in the GPT-3 work of just saying, okay, let's train this on let's make the biggest model we can and train on as much stuff as we can from the web. And then let's start seeing whether it can have some form of what we call emergent behaviors, such as doing what we call few shot learning, where we just give a few examples of the kind of task that you want. For this input, I want that output, and this input, I want that output. And then seeing whether if you give it a new input, the language model will have somehow learned what is the task that is being asked to solve by doing a bunch of examples of input and output pairs. And I would not necessarily honestly have guessed that. That was to me like that remains one of the most exciting results that I've seen in the past. Now it's more than a year, so maybe a couple of years. Um, and that's definitely like very very exciting and opens up a lot of possibilities of the kind of things we might be able to do with that kind of technology.
Yeah, it feels like hearing you talk. It's like it doesn't feel like we're going into a new winter. Like if you go back to that exponential curve, it's just like there seems like now it's more a question of diffusion of like taking all these ideas and just applying them to every sector of the economy. At
Yeah.
least at least what it looks like. Maybe then, what's the research that you're more interested in, like sub segment or or research that excites you the most from other people?
So there's a few things, and a lot of that is inspired from all the researchers that are in my group and doing various things. Um, I One of the application of some of these ideas of really large models trained on language like models has been in software engineering and supporting the writing of code. So there's been some really exciting results in that respect, leveraging similar ideas that's behind GPT-3, but for code generation. And there's a lot more that we can do here at Google. We have the chance of having access to a lot of our own developers' data, historical data that we can use to learn and do interesting things with it. One of the early things that my group has done is to produce a system that was able to propose changes to code that would fix building errors. And that was kind of the first prototype that the part of my team that is looking at machine learning for code, that's led by Danny Tarlow, decided to try out to try to see, can we use Google's own internal data to help our developers solving a particular kind of task that it seems we do often, and perhaps there's a lot of data historically from previous code that was written by our engineers that would allow us to kind of generalize a capability of doing that more automatically. And that has had a lot of influence, and now that's an area that we're really excited about, and I'm really proud that my team has been able to really advocate for at Google, and is something that not just in Montreal but in Brain in general, we feel we can have a big impact at Google. So that's one area that I find really interesting. um, Generally, the main theme of my research across the years has been, how do we develop models that can solve new tasks from small amounts of data. So I mentioned few shot learning, so that's one term for it. Um, so essentially transferring what we've learned from previous tasks that we've learned to new tasks that we can learn the next task more rapidly. And conceptually, the idea is that we learn new things pretty quickly in terms of the amount of experience, which is kind of the data for a machine learning model. We don't require a lot of experience to learn new things. Whereas you can think of our machine learning systems as oftentimes actually typically requiring tons of data to until they can actually solve something really well. And this is less and less true, but there's still a gap. And closing that gap is kind of my long-term research agenda. And I've been interested in developing methods that are trying to do this in sort of a more general way, sort of trying to think about principles for doing few-shot learning or transfer learning that is effective. Um, and I have been increasingly interested in applying this in areas that are a bit more overlooked. So I think I've liked doing in my research career, sort of whenever something gets really popular, I like to start thinking, okay, what else are we not doing then? If anything, for my own sanity. When you're a researcher and you're working in an area that's really popular, then you're always concerned you're going to get scooped. So if anything, so that my day to day is less stressful, working on things that I feel like more or less alone or not a lot of people are looking at is kind of I think a good service for myself. Um, and I've been more and more interested in the area of remote sensing, in particular for applications related to the environment. So, a particular task that I'm looking at, and actually mostly with people at Mila and students at Mila, is to use satellite imagery to be able to make an assessment of what's the probability of observing different types of species in that area of the world. And that could lead to a tool that helps us monitor the development of the planet and what impact it has on biodiversity, for instance. And uh, we can think of some problems in that area as essentially requiring an aptitude for few-shot learning or requiring a form of transfer learning to sort of be able to generalize to new species or new territories or generalize well to the future. And so that's something that I've paying more and more attention to these days.
Yeah, interesting. Yeah, and there's real world applications, right? Maybe
Hmm.
the double click on those first two, like the first one, like this notion of like software engineering. Like, there's this common trope of software is going to become a commodity. So
Mm.
if you look at like GitHub Copilot, for instance, it's like code will a
Yeah.
large part of it's going to be being written itself. So I imagine that's one real world application. The second one, you mentioned one the environment, but would you also maybe include robotics in there? So it's like being able to using machine vision and then deep learning for a robot to be able to repeat simple tasks and then you almost be able to have like a general, like the Optimus that Tesla's building, right? Where it's like, hey, it's able to help you a general purpose robot at home that
Mhm.
helps you. Is that a good, let's say,
That
application
No,
of what you mentioned?
absolutely, absolutely. It's actually maybe of the three we talked about, probably the hardest. I think we do a lot of embodied learning for our own ability to manipulate objects, and that's something that's still hard to do on a real robot. Uh, and But there's a lot of progress that's happening, and actually, Google Brain or Google as a robotics team that is making some really exciting progress in that area. But if, for instance, just if I show a new object to a robot, you would want it to kind of fairly quickly grasp, okay, what is it I can do with this object, and how can I manipulate it, without having to sort of test out manipulating multiple times, or being able to recognize other objects of that same category, but that maybe has slightly different appearances. That would be an example of a potential few shot learning problem. So that's definitely an area where this kind of technology or methodologies of doing few shot learning would be useful.
Do you believe in this like this notion of like AGI, like consciousness? Is this like kind of like is this like a Twitter thing in the sense of like dumb people like me that hey, is this a real thing? A lot of smart people talk about it, or is it so far removed from let's say just something that we can actually track,
Right.
research, study, right? Like we don't have the first clue of what is consciousness, right? So
Yeah.
yeah, curious to pick your brain.
Yeah. I've not looked that closely. Well, AGI is something even before we started talking about machines being conscious and whatnot. That was a concept that was being debated. I never engaged in sort of that narrative too much, and maybe I tend to be more conservative in my projection of how fast our progress could be. So I've never really sort of embraced that perspective too much. I also kind of prefer thinking of what I do of not really trying to enable AGI, but just trying to, create technology that's gonna create tools that are useful to us. I think I'm much more motivated by the idea of creating technology that allows us to be more creative and that handle a lot of the repetitive tasks that we do, as opposed to replacing us, completely. The example of software engineering and providing tools or assistance effectively for programmers, I think is a good example of that. Uh, and consciousness, I think it's a really interesting thing to debate. It's a philosophical debate, really, in a way. Like, I don't think we really know what consciousness really means. I find it interesting because really, in the end, it's kind of even debating all of these things is also a way of like debating what we are and our own nature, and that I don't think we should be against that. Um, I would uh, try to not sort of use that as a way of hyping everything what we're doing, but it certainly makes part of what I found interesting in doing machine learning and working in AI has been indirectly also sort of asking questions that might perhaps tell something about our own intelligence. And that is something I like about this field and about potentially discussing, when is it that we would think we would achieve consciousness or something like that. I'm not of the impression that we're that close really to doing this, but that's partly because I think we don't have a particularly good definition of what I would mean, anyways. And in any case, to me, that's not even a goal. Like, I don't think of that as this is a goal that we should achieve. I think the goal should be let's create technology that's useful to people, beneficial for humanity. And it's unclear to me that consciousness is like something that's required to even get there, if at all possible. Yeah, but I think also it's what I like about this field and working in it, and the kind of discussions we have, is that sometimes we also realize that we ourselves are not that smart, or some of what we are doing we thought really required deep intelligence, and turns out no, it's like we're more or less also doing pattern matching, and so it's not saying that our machines are super smart. It's more like, oh, actually, when we do this, we're not being as clever as we think we are. We're just doing pattern matching, or a somewhat clever form of pattern matching, and that's kind of humbling, which I kind of like. So, at least I like when we have these moments. I think it's a good experience to have sometimes.
Yeah, it helps us understand better who we are, right? Like
Hmm.
as a species, and right. Given the sense you mentioned this, the exponential growth, like where you situate ourselves today, end of 2022, I feel that there's like going back to this groundswell of new cool things happening, but also given the, I guess, yes, the end of the pandemic, or this phase of the pandemic, I'm not sure where we're at, that you we realize that there's a bunch of smart people and they're anywhere on the planet, right? So it feels like there's many more people that are able to contribute to the field. So what do you expect happening next, right? If you have to like project, 12, 24, 36 months out, what
Mm.
happens to the field, particularly when it comes to research and deep learning?
Oh, that's a great and difficult question. I'll, which I'm not even sure I'm going to be able to answer. I will at least first say that I have been overly conservative many times. Um, Even when I remember when we had what we call the image net moment, which is when the um, for the first time where a neural network blew blew the competition away at doing the recognition of images in natural images, of recognition of objects in natural images. Um, I thought, wow, this is amazing. I wasn't sure we were gonna get there so quickly, and now we probably need to wait a little bit more before we see another kind of amazing moment like that. And it didn't take long until we achieved something that I would say somewhat similar for machine translation, where again neural nets started being just the preferred and the state of the art technology for doing translation, say from English to French and so on. And surprisingly, that kept happening. AlphaGo, and so on and so forth. So the main thing I can say is I will probably be surprised. I will probably be surprised by the pace of things, because I keep thinking that maybe we're going to get to a point where, okay, we need to sort of rethink the fundamentals of what we're doing, because possibly there's something we're not getting that's really sort of crucial to get to the next step. And it's not really happened. Like we have senses of things that we know, like are difficult. Generalizing to completely new situations, doing what we call out of distribution generalization, uh, is something that we know to be hard, um, and that is quite possible. That's going to require that this is sort of an obstacle of our ability to solve certain problems, perhaps notably in robotics, but other settings as well, and where just training on as much data we can get our hands on might not be sufficient. And that's why it's important, I think, in my team and in general in the research community, that we have like a fairly rich portfolio of kinds of research that is being explored. It shouldn't just be about studying, what's the next way, like how to train the next biggest model on the next largest data set. It should also be about inspecting the fundamentals, seeing that, the things are really driving these larger models. Are there ways of doing that better, more efficiently, in terms of amount of data or in terms of amount of compute? I think that's still sort of necessary. When will we get to a point where we sort of are blocked by our inability of innovating on the fundamentals? I find it. I don't know. I don't know if it's around the corner in some time. So yeah, I mean that's a it's a, not quite the answer, or not the most exciting answer, but that is kind of how I feel, and I suspect I'm not alone. Like the main thing that I suspect is I'm going to be surprised.
Maybe, I was going to say, maybe the surprise is going to be an algorithm that's going to help us get there. It's going to be the one that tells us, right? So that's kind of the wild part, because if you look at breakthroughs like AlphaGo and like AlphaFold, where it was like, again, very simplistic understandings, like brute force of like massive compute, really like just like calculating all the possibilities and like being able to predict better than humans can. But to your point, what I find fascinating as a concept is like challenging even those core blocks and coming up with something even better.
I can say one thing that I am hoping for, and AlphaFold is an example, but of more machine learning and AI enabling new scientific discoveries. And I I see there's a lot of activity like in that area. I am hoping, notably, that this can lead to scientific discoveries that might help us, for instance, fight climate change, or just being more energy efficient and so on. So I dare to be optimistic that this might be an important factor, and that AI might be able to help in this way for problems that are quite crucial and that we need to address as a society.
Yeah, maybe to ask a few personal questions on that front, because you mentioned, helping people, help society. We're obviously together. We're on Tech Aid, trying to do small things in the community. You're obviously, if like you help create, the Mila AI conference to raise a bunch of money. And we were talking about also this notion of climate. So I'm not like, maybe give a segue into like talking about just your philosophy about
Mhm.
using technology to help out people. I'd love to hear about how you
Mhm.
think about it.
Yeah. So for those who don't know about TechAid, this is a group of people from the tech industry in Montreal, just trying to raise awareness and try to mostly raise money for Centraide, or United Way, an organization that supports many organizations fighting poverty and social exclusion in Montreal. And I got to know about TechAid when I started at Google, because there were already people in the office that were involved in that group. And there was this kind of fundraising event that was organized, and I thought it was such a great initiative, and I just felt compelled to be able to also participate and give back. And at the time, I'd just come to Montreal. There was a lot of excitement about this rise of AI, and Montreal being sort of a particularly exciting place to do AI, and there were a lot of appetite for events and conferences and presentations of the various experts in Montreal for that. And so I thought maybe we could organize an event, an actual conference that is actually a technical conference, one that I would like to go to and learn from, but charge not a whole lot of money, get sponsors, and use all of that money to sort of give back and give it to Centraide. And the first event we did was really successful. We raised over $100,000. It was a fun event too. So it wasn't just about mostly collecting money. My thinking was, I don't want to be disappointed by the amount of money we raise. I want to be happy that we've organized this fun event. And it so turns out we also raised money. But it went beyond, my expectations. And then we decided to sort of do that regularly. Um, and I've found, getting involved in forms of philanthropy and giving back like that just really, really rewarding. And so in a way, it's not something I feel I need to do, though. I mean, it certainly started from the point of view like, okay, I'm in a pretty privileged situation. I should try to use that privilege and make others benefit from it. Also, once you do it, it just gives you such a warm and satisfying feeling that I've really enjoyed sort of finding that community tech aid and be able to contribute to it. I was talking about also wanting to, or seeing technology and AI being particularly useful to fight climate change and work on fundamental problems of uh, uh, solving some environmental issues that we're facing. Um, and so this year, me and my wife, we decided we wanted to make a bigger gesture in that direction. Again, sort of being quite sort of cognizant of the fact that I was really lucky to go to University of Montreal, meet Joshua Bengio, fall in a field that became really, really important and popular, and that led me to a really great job in industry, and even led me to have my own startup and sell it. So we kind of thought it might be nice for me to give back, and maybe us to give back, me and my wife, and maybe do a big gesture that might sort of get inspire other people to perhaps do the same. And so we're planning on giving $1 million to the University of Montreal to create a new scholarship for PhD students that would work in AI, but dedicated towards applications for solving certain environmental problems, such as the reduction of biodiversity, so fighting that, and fighting climate change. And so we're just about to get this going. So we're recording this now. We haven't even announced it yet, but that's about to happen. Really excited about it, and it took some time for us to kind of like uh, get them save the money for us to be doing this big gesture. But hopefully this sort of inspires others, which is a lot of, we want to help students, we want to promote this area, but hopefully also we want to sort of promote the idea of doing this kind of gestures when you're in a position to do it. So yeah.
Yeah. Hats off, man. Hats off. Congrats on that on that amount, and like obviously for a cause that I think everyone on the planet can understand, right? Like climate change. Like we're living in like the warmest. It's like on one side it's like the warmest fall ever. On the other side, you're like, this is not normal.
Mhm.
This just doesn't make sense. So I think the urgency of it, I don't think we realize. So like, hats off. A few points you mentioned, role models. I think that's a great one where not everyone can give back the amount you just did, but I think you're always saying it's like, hey, one small step can make a difference, right? So it can inspire others to start giving back and contributing. And maybe a tactical note is like, have a landing page when you announce something, collect names. Like, people will be inspired by this. So it's like, have a way for people to like want to give back, because I
Mhm.
think it is something that's quite inspirational.
Yeah, I mean,
Would you have any?
when we had this conversation I first approached the university and I said, I want to give back to University of Montreal because I really am thankful for the opportunity that it gave me down the road. Uh, Maybe even as an anecdote, and this is, I've said that in other forums, but if anything, just to remind me how lucky I am. When I applied to the university, I applied to both McGill and University of Montreal. And I got accepted to both. In fact, I had a better scholarship for McGill than I did University of Montreal. But I picked University of Montreal because at the time I wasn't comfortable with my English. I was concerned I was going to struggle at McGill or have a harder time. So I still went for University of Montreal. But in a way, like I think, if you'd ask someone, which university has the better international recognition, you'd probably pick McGill. But this actually led me. So it didn't seem like locally to be the best choice to make, but it led me to meet Joshua Bengio during my undergrad, doing an internship in his lab during the summer, so I could sort of dump my job at McDonald's and instead do some research and learn to do research during the summer. And this was a huge influential decision really as to where I am today. So I'm really, really lucky and quite cognizant of that. And so I so realizing that I this is why I wanted to give back to University of Montreal in particular. And when I approached them, I just want to do this nice gesture, and I'm not doing this to get any recognition for it or anything like that. But I'm having been at Take 8 and sort of having learned a little bit about what are good strategies for sort of uh, getting to raise more money in by Centraide and so on. The reality is that like giving examples like that, so showing that yes, some people are giving and is actually generating itself other people that give, and that in itself is sort of a gesture also. And so I believe University of Montreal is kind of handling that. I don't want to. I'm like, if for some reason you don't want to talk about it, well, we don't have to talk about it. But if you want to talk about it because you think it's useful, and because we know, like, I think there's lots of evidence that it is, then I believe they will be handling that part, hopefully.
Yeah, no, for sure. But I like the point you mentioned about, hey, like you kind of feel, I don't want to say shy, I don't know what the right word is, but like, feel like, oh, like, to make a big fuss of it.
Mhm.
You don't want it to be about you, which
Yeah,
I
that's right.
agree to. But at the same time, it's like you also have a platform, you have a following, you have a voice in the
Mhm.
field. So a little bit your duty also to kind of like
Mhm.
use that platform for good, right, instead of evil, for sure.
Yeah.
So I think, and as going back to the problem at hand, we spoke about how climate change, and like, I'm not, obviously I think it's a field that is so complex, yet going to be rising in importance. One of the ways we're going to need human ingenuity, right, and with all of our best tools, and the best tools we have today are coming out of like the kind of work you're doing, right? So it just makes a lot of sense to be able to apply that to solve the world's biggest problems.
Mhm. Yeah, I believe so. Yeah, yeah. Specifically for climate change, it doesn't change. There are lots of things that we can do, and it's not just about giving money to particular projects and so on. It's also our own individual choices. I happen to be in a situation when I can try to do both, and so that's great. But in particular for us, I knew I wanted to give to University of Montreal. I knew it was probably going to be something related to computer science, and I thought AI was kind of a natural choice. And talking to my wife, she felt that was maybe a bit too broad, and she, well, much like myself, had an interest in and a concern about our environment. So I thought, okay, maybe we can sort of look at something at the intersection, and which is not an area where there's a whole lot of AI. There's a growing sort of community and growing voices that are saying that this might have a role, and but certainly not as much as other application area. So that kind of felt like a natural thing to try to support.
Yeah, I've spoken to a few like climate tech investors, a few climate tech
Hmm.
startups, and it's just such a new field, right? And it's also one I think just more impactful than social media, right, or any kind of other like existing domain. But here it's one that has a real impact, but also huge commercial application. So it doesn't go against the grain of like, hey, you can also actually build something for yourself to
Hmm.
to make profits and grow, but also does good in the world. So we're really an interesting space, particularly in Quebec and in Canada, where we have a lot of natural resources, being people, tech,
Hmm.
and energy to be able to find solutions to some of these problems. So yeah, I think it's a good time to have made the move you made.
But also, like, no matter how much time that it takes for a particularly important and crucial technological breakthrough to mitigate various, or fight climate change in various ways, uh, just the fact that we'd be supporting students that will get to focus on their research, that was something that I also felt privileged, is that though I don't come from a rich family, but my parents fully supported my studies, and that's not something that everyone gets to do. But that allowed me to really focus. I have no money concerns, but really focus on learning, growing as an academic, and that also is very important. So we'll also get to do that, and yeah, and though that new generation or that next cohort of scientists and researchers might be the ones who create the next startup that will actually bring some technology that's going to be really valuable. So I'm looking forward to seeing that.
Yeah, I don't think there's a better place to end the interview. Hugo, this has been such a treat. Obviously, hats off, congrats for the work that you're doing, both at Google Brain and obviously with your philanthropic endeavors. A final question is: if people want to reach out, connect, learn more from the work that you're doing, what's the best way?
So they can follow me on Twitter if Twitter still exists when people listen to this interview. But Hugo_Larochelle is my handle. And if you Google me, you'll find I have my website on Mila, for instance, where I believe my contact is there. Those are probably the best ways of reaching out to me and seeing what I'm up to.
Hugo, merci beaucoup. It was a real pleasure.
Sure thing. Thank you.
As always, thanks for listening, and don't forget to subscribe. If you want to learn more, check out thepnr.com.